Let's finish up 2-2, practicing problem solving on Envision over rational numbers. So this chart's pretty cool here. When you pull this up, you'll see natural numbers are 1, 2, 3, 4, 5. Whole numbers are natural numbers, but it includes 0. Now, integers are whole numbers in their opposites. So this is like 5 and -5. So these are positive or negative whole numbers. And rational numbers are all of these, and they can be put in the form of a over b. For example, let's look at 3. 3 can be put in the form of 3 over 1. So also 1.5. These are also fractions. So like 1.5 can be put in the form of 3 over 2. See that? So these include fractions and decimals and all that. But if it's a decimal that does not have a pattern, then that's an irrational number. And you'll get to that in 7th grade. To which sets of positive integers belong? So positive integers are natural numbers. They could also be whole numbers. They could also be rational numbers and integers. The fewest number of points you must plot in order to have examples of all 4 sets of numbers, including at least 1 positive and 1 negative. So that would be 2. The rational numbers, whole numbers. So now, suppose you plot the locations of certain bacteria species in a lake on a number line. Which species would be represented by the point farthest from 0 on the number line? So let's see, which point would be farthest from 0 on the number line? Wow, well, they're all pretty close. I can see how someone would get confused by this. I recommend making a number line and showing this. Like, this is about -1, less than -1. This is pretty far away. Do you guys see how far away this one is from 0? So I think it's species C. This is a little over -1. Yeah, so I would say sometimes you just visualize the number line in your head, and that helps too. So species C would be farthest from 0 because -3 1/4 is to the left or below, like below if it's a number line, like a thermometer type number line, of each of the other numbers on the number line. Which species is closest to the depth of -1 and 1/6? Let's see, which one's closest to -1 and 1/6? That one I could see how they're trying to trick you to thinking that. That's -1 and 1/2. Let me look at that fraction again. Where'd it go? Where'd it go, guys? Okay, -1.6. -1.6. So I think it is that one. Let me just see if any of these others. No, yeah. So which one was that? Don't you hate when that happens? Species D, okay? Species D. Hope you're having a great day today. The change in the value of a bank account is represented by a rational number, $2.30, or 2 30/100. Describe in words what this means. So this would be positive. It rose by, now if it were negative, that means it would be subtracted, right? But good thing you got money in there instead of subtracting money, right? Am I right? Let's see what this says. A classmate ordered these numbers from greatest to least. Is he correct? Construct an argument to justify your answer. So that's greatest. That's good. Okay, do you see what's happening here? See, when you get into the negatives, it's almost like backward. And this number here is greater than it, because on a number line, this number would be right here, and then this number would be farther left. So no, -7 and 86 6/600 is to the left of -7 on the number line. He should have switched the last two numbers. Visualizing a number line is really helpful, I think, in this lesson. Lots of number lines here. Lots and lots of numbers. Don't you hate when the spinning wheel just keeps spinning and spinning and spinning, spinning and spinning and spinning, spinning? It's still going, guys. Can you believe it? Can you believe it, guys? Well, this is awkward. While it's waiting, look, see the coin? See the coin? Watch. Gone. You think it's funny, but it's not. It's not. You guys want to learn how to do that? I'll show you. This is kind of a bonus. We're going to come in here, and it looks like I grab it, but it really fell right here. So I'll show you. So you come up, drops down into my hand. I pretend to have it, but it's really right here. Pretend to have it, and you go, gone. And then this hand that has it in finger palm, see finger palm position? Blows it out of your nose like that. I'll show it again. This. This is the finger roll. This is fun to do when you're waiting on something. Kind of like this circle spinning thing. Hopefully this speeds up a little bit because I got my students coming back here soon. There you go. Well, hey, that's just a bonus. I'm going to go ahead and end this video now. All right, guys, so it started to work. Would you look at that? Look at that, guys. Suppose P over Q, R over S, and T over U represent three rational numbers. If P over Q is greater than R over S and R over S is greater than T over U. Anyone else has explained it? So let's see. Let's just break this down, guys. If P over Q is greater than R over S, and R over S is greater than T over U, that means P over Q is greater than T over U. On a number line, P over Q, so I'm actually going to draw this number line for you guys. I can sort of visualize it. You might not be there yet. So here's a number line. P over Q is here. It's greater than R over S. R over S is here. And this is T over U, okay? So P over Q is to the right of R over S, and R over S is to the right of T over U. So P over Q is right of T over U. Well, that should work. Hope that. See, just drawing out the number line, again, to reiterate, that's really going to help you a lot. Okay. Thank goodness we got that done. I was worried that spinning wheel, but we got to see a magic trick. Which inequality is not true? Well, this equals 2 1/4, guys. 2 1/4, but 2 1/2 is greater. Now, -3/5 is less than 3/5. Remember, we're going not true. So don't. -8 is greater than -9. Yeah, because on a number line here, this is 0. This would be -8, and this would be -9. So -8 is further to the right. See how -8 is further to the right? And if it's further to the left, it's less than. So -2 1/2 is greater than -9 9/4. Well, here they're trying to trick you because -2.5 is less than -2 1/4. Remember, it's kind of backwards of what you would think. Okay, so that one's not true. And one more, guys, then we'll call it a day. Then, oh, here goes the wheel. Oh boy. Oh boy. Oh boy. What can I do? What can I do? There. There we go. Practice my magic for you. Oh, wait, going this way. So that goes like this. Teach you like that. It comes up, see, like that. It's called back palming. Uh-oh, here we go. Here we go.